So today, my talk is on real-time fraud detection at scale and integrating deep link graph analytics with machine learning, Spark AI. And have everyone here used like graph in your machine learning process? Any graph features? Okay, I see there's some experts here. So hopefully I'll bring some new elements to your machine learning pipeline. So my name is Emma Liu. I'm a product manager at TigerGraph, and I work on a lot of features. For example, TigerGraph Cloud and also ecosystem connectors, enterprise features, monitoring features, admin portal. So there are a lot of things that I'm not going to cover in this talk. So if you guys have more questions, just ask me after the talk. I want to start with this quote from Gartner. Gartner said, graph analysis is possibly the single most effective competitive differentiator for organizations pursuing data-driven operations and decisions after the design of data capture. So this is actually very, very powerful. And Gartner also predicts in the next 5 years, there's 100% year-over-year growth in graph database and graph analytics market. So it is a very important new trend that you should keep in mind for your data pipeline. All right. I want to first talk about graph is how we think, right? Just think about everything around you. Everything around you, everybody around us, all the entities are connected somehow in graph. And locations, events, purchases, all these can be transferred, these interconnect data can be transferred into deeper insights and provide some of the use cases in recommendation, giving you new products and predictions and supply chain and cybersecurity. All those are very interesting use cases for you. And today, we're connected through Spark Conference. And if we investigate our relationships, we might be connected through schools, workplaces, and our interests in AI and machine learning. So a lot of these are connecting us into a big graph. And I want you to think about the phone. Maybe it's in your hand or in your pocket. Actually, every day, you're using graph in your phone. If you have Google doing a search, if you are using Facebook, if you are using LinkedIn for your professional network, and also using Twitter for your news feed. So all these are powered on big graph. And these corporations achieved high value because of the graph underneath it. And what TigerGraph wanted to do is actually bring the graph analytics to everyone, to bring to the enterprises, small, medium, large enterprises that don't have an in-house power to develop a solid graph database. So that's our mission, to bring the power and unleash the power of interconnected data. A few users use TigerGraph to do three main things. First, to increase the revenue, to reduce the cost and manage risks, and improve operational efficiency. So our users achieve it in a few of the use cases. For example, recommendation engine, real-time customer 360, entity resolution and MDM, fraud detection and anti-money laundering, and also network and cloud resource optimization and supply chain analysis. Just to name a few, we have a lot more use cases. I'm not going to go into detail with all these use cases. Just find me and TigerGraph staff, and we can go into detail about your specific use case. I want to spend a little bit of time on the 7 key data science capabilities powered by a native parallel graph. First, what is a native parallel graph? TigerGraph is a native parallel graph that, in terms of native, we store graph natively, and we compute on the vertex and edge. Vertex and edge are the main entities and first-class entities in a graph database. And in terms of parallel, we're talking about TigerGraph is built on a MPP architecture that empowers the parallel processing. And these, both of these attributes really brings the performance and storage compression that comes with the TigerGraph platform. And there's a top 4 that has a few of the graph representation that will help you to think about some of the patterns in your data set. For example, the deep link analysis. When we talk about deep link, we're talking about 3 hops and more relationship. You're finding the relationship among the entities in your data set. And when I talk about one hop, it means from first vertex to the second. When I talk about 2 hops, it's first jumping to the second vertex and jumping to the third vertex, and so on and so forth for deep link analysis. TigerGraph can actually do more than 10 hops with sub-second performance. And the second one is query pattern. With query pattern, when we are given a query pattern, you can find other similar patterns in your data set. It's kind of coming up with a subgraph, little subgraph in your database. And the third one is actually finding the relational commonality of given entities. For example, if you're given 2 customers, 2 patients in your data set, you can think about what is the patient journey. Are there similar patient journey that I can recommend similar claims, similar medications, or similar doctors to another patient? Or a customer journey. When you think about Customer 360, how do people purchase certain products? And you can actually find similar paths that can recommend different products and also think about the target marketing. And the fourth aspect is hop and community detection. This is a very prominent, important graph algorithm that empowers you to find the most influential members in a group, and you can also find communities in that group. And 5 and 6 are adding the time and geo dimension on top of the deep link analysis. So this is adding another 2 dimension that really gives you more of the power in the deep link analytics. And 7, I'm going to talk about in the next slides. Power explainable AI with TigerGraph. So this is a very popular concept now about explainable AI. When we start, we have gone through a few of the phases in computer science. The first phase is the procedural error that we give rules and predict the outputs. And the second part, when we get to the machine learning phase, is when you are given data and answer, you come up with a machine learning model, but you cannot really understand what it actually means. It's a black box. When you provided the model to predict the result, it's hard to explain how you actually arrive to that decision. So explainable AI is the third phase that you can actually think about how to explain different rules in the machine learning model so that you can help your customers and users to determine, oh, how I get to that decision, right? For example, this is actually really important to many of the industries, for example, governments, insurances, banking. Just think about when a patient get a claim rejected, he or she deserves to know that why I got rejected, right? It's not just a black box. Oh, you got rejected from machine. We actually need to be able to explain that. And Graph is actually a perfect platform that first, when you get the graph-based feature extraction, getting into the machine learning process, and you can actually explain and validate and predict the model, putting into the graph database. And you can explain the model using this interface and tell your user and customer, OK, this is how we get to a certain decision. So explainable AI can be powered and enhanced by TigerGraph. So why Spark and TigerGraph together? I want to talk about first the reference architecture between Spark and TigerGraph. Spark, many of the data sources can go into Spark and getting claims and going through the ETL process. This is the first step. And then it feeds into TigerGraph, which is TigerGraph is both a OLTP and OLAP platform. So it can serve as system records, but it can also do the real-time graph feature extraction for the model training. And when you get the graph feature, you can feed back to Spark, and Spark would do the model training. And after the model is trained, you can feed that model back to TigerGraph. And from TigerGraph, you can do the real-time prediction from the model with real-time streaming data as well. And on the downstream, you can feed the result and outcome to the graph applications and BI tool, and also the visualization tool through the REST API. So putting in words, there are a few of the typical Spark and TigerGraph integration. in data preparation and integration, both TigerGraph and Spark can do. I want to mention that TigerGraph can actually do advanced ETL process involving entity resolution and MDM. So that actually can help Spark to do the data cleansing as well. And the second, unsupervised machine learning. TigerGraph, because of the graph algorithm, you can do many unsupervised machine learning algorithm in TigerGraph. For example, community detection, hub detection, and things like that. And the third is feature extraction for supervised learning. Both TigerGraph and Spark can do feature extraction for supervised learning. And TigerGraph especially excels at the real-time graph feature extraction. And in Spark, you can do model training. This is a very common way that people bring to our use case. OK, we have Spark in our data pipeline, and we're using it for model training. And how can you integrate into our existing framework? And I want to mention that in the end, I will give a sneak peek that within TigerGraph, we can also do model training as well. We actually did a project on neural network model training. The next step, TigerGraph can apply the model. And in the end, TigerGraph can visualize and also explore the interconnected data. Now I'm going to transition to the use case with machine learning and TigerGraph. It's on the China Mobile anti-fraud and scam detection. So OK, now I want to find the lucky one and lucky few in the crowd. OK, so just raise your hand if you have not being bothered by robocall or scam call in the past year. Raise your hand. Oh, wow. You guys are really lucky. I was thinking maybe just one, and this person can come up to be my volunteer to finish my presentation. But I'm assuming that you guys have some software installed in your mobile phone, or maybe you're from European countries that actually have strict data governance rules, right? All right. So this is actually a very massive and worldwide problem. And in 2017, there's 18 billion robocalls in the US alone. And in terms of the spam and the scam calls, it actually has the feature of being very agile. And people have different ways to do the scam phones. And you also have the spoofed phone numbers, and they pretend to be some police phone number. I actually got called and pretending that they are Massachusetts police station, and asking about a lot of information from me. I was like, OK, that's not right. Like, they're probably not going to call me to ask about those personal questions. OK, our customer, China Mobile, in China, this is actually a pretty big problem as well, because you can buy SIM card really fast. It's really cheap to just get the SIM card and call a bunch of people, right? And also, they actually have other ways to do it in a more advanced way. So in China Mobile, we're actually working with one of the province. Even in the Shandong province, there's 600 million subscribers in-network and out-of-network phones in this specific province. And the load is about 300 million calls per day. And at the peak, it has 10,000 calls per second. So it's a very big number and a high transaction load. And they really need a real-time detection of this various types of phone-based fraud, just because the way that they do the spam phone call and scam is changing very rapidly. So what we recommended to our customer, China Mobile, is doing a real-time graph-based machine learning and decision system. As I mentioned earlier, TigerGraph is actually an HTAP solution, which is a hybrid transactional analytical processing platform. And in terms of the graph database, we input the 600 million phone numbers inside and outside network into TigerGraph. And there are actually 15 billion phone-to-phone call edges, and this is only a 2-month sliding window with the time and duration on the attributes. And at the peak time, I mentioned there's 10,000 calls per second update. And for this platform, we used 118 graph features per phone. And in the analytics side, inside TigerGraph, we did real-time machine learning and getting the 118 graph features per call at real time. And for the model, we actually retrained periodically with 2 million phone calls. And for the real-time decisions, when a phone call reaches your phone, on the screen, you will actually see immediately whether it's a scam phone or a sales phone or a harassment phone call. And this system is actually in production since December 2016, and it's still running pretty well. As I mentioned, we collected 118 graph features, and I want to talk about just a few of these graph features. So we have this comparison of a good phone and bad phone. How are we classifying a good phone and bad phone? So there are a few features here. If you look on the left side, the brown circle, when you have labeled stable group. So the source phone is phone 1. It has called phone 7, 8, 9, 10, and they also called back. So that actually indicates that there's a trust relationship between phone 1 and these other phone calls. So we call this as a stable group. These phone calls are probably in your contacts list. And then we're looking at the bad phone. Normally, this phone 1 doesn't have the stable group, so it's empty on the right-hand side. And then let's look at the green circle, the many in-group connections. So this is another feature, graph feature, that when phone 1 calls 5, 6, and 4, we find that within this target group of phones, they also have connections. So basically, this is a group of friends that you call frequently, and they actually call each other as well. So this is a good indicator that it's a good phone. And it's a very common graph feature that you can get from a graph database. And when you have, on the right-hand side, when you're looking at the bad phone, it doesn't really have this in-group connection. And the third one is the red line here, phone 1 to phone 4. This is what we call a long-term phone. How we're defining the long-term phone is, for example, you call your parents, right? And you might not be calling daily, but you can be calling a weekly or monthly cadence. But you have established a long-term relationship with this phone. So if your phone has such feature, it also means it has high probability to be a good phone, right? So I'm just going to explain these 3 features here, but basically these features, about 118 of them, we collected them and put into the training, and the machine learning process will tell us what are the different weights we put into the different feature. All right, looking at the process here, when the real-time call event happens, there's the caller, callee, and time, and going to the query into TigerGraph. And TigerGraph will determine, okay, whether it's a fraud call or not, and it will show up on your mobile device. And we also have another call detail records that already record what are the different fraud type on the different numbers. So these are, after the phone call, we actually put back to these records so that next time you don't have to go through this prediction and training graph extraction again. So you have it already indicated in your database. And when this process goes through, you will be able to know, okay, whether a phone is a good phone or a bad phone. As I said, we run real-time G-SQL query for each phone, and we use one G-SQL query and collect 118 features. At the same time, we also compute the composite score, and also update the fraud flag, and also return the fraud type. So here, the graph schema for this this model is actually pretty simple. It's a phone, and the edges between phone and phone calls. And so that's the edge. To simplify, there's a lot of call events. We didn't put every call event to be a phone-phone edge. We actually aggregated some of the information on the edge between different phones. That's the number of call and total duration and call date and also number of rejection calls, right? And on each phone, there's the fraud flag. Either it's already labeled as fraud or not, and also the expiration time. So we actually keep the fraud flag for a period of time. We clear it out after maybe 2 months time frame, so you can control that as well. This is basically also adapting to the nature of the fraud scam, the algorithm. So in this big graph, there's 600 million vertices and 15 billion edges and 300 million daily updates. Again, case 1, when the call type was recently flagged, the real-time call event going to TigerGraph, and if caller was recently flagged as bad, it will show up as a warning. And the second part, when the call needs to be classified, it goes through the classifier and with the real-time collected graph features, and it will update TigerGraph as well with the fraud flag. And if the caller is classified as bad, then it will show up real-time in your phone. It's a bad phone. So the input here is a list of calls with phone pairs and call time. And we also do that in batch. An output is the call fraud type. And here, we also output the scoring and feature vector of fraud calls for supporting evidence. So the second part of the output is actually asked by our customer. We were originally only outputting the call fraud type, but China Mobile was asking, okay, why did you reject certain of the fraud calls, right? So we came up with the scoring and everything. So this comes back to the explainable AI. A lot of customers actually want to know how you arrive at certain decisions. Putting different steps here in machine learning workflow for the China Mobile case. The data labels are from the police reports and the online third-party sources, and the 118 graph features collected in one GSQL query. And the training data feature also collected in GSQL in batch and stored in CSV for the future model training. And we actually perform in the platform multiple machine learning models in real time. And finally, the machine learning models are trained offline, and the model parameters are stored as configuration files for GSQL to use for real-time scoring. And in the future, all these will training machine learning models in Spark. Okay, some of the benefits using TigerGraph to do machine learning. You can do the real-time scoring with multiple machine learning models in GSQL. And it's very fast. You get the real-time response for both the feature collection and scoring at the same time. And the second, it's super efficient. There's a concept in TigerGraph that you can aggregate through the traversal, graph traversal. And you can get multiple features in one traversal, one attempt. And it's super easy because you can collect really complex features, those graph patterns, without multiple relational RDBMS joins. That's going to be really slow for these graph patterns. So the results for this use case with the TigerGraph machine learning solutions. So in 3 years, we actually detected 3.2 million fraud notifications. And we also saved, the local police department actually estimated that we saved potential about $6 million US for the Shandong province. Again, why Spark and TigerGraph together, right? So here's some of the benefits when you combine TigerGraph and Spark. TigerGraph can enrich the machine learning process with the complex graph features. And TigerGraph and Spark are both parallel processing built in MPP, and it's distributed systems. And both are very good for training and ETL and feature collection process. So the combined data flow actually would do this job really well. And you can capture a lot of business moments with real-time response with explainable AI. And everything is at scale for big data. You want a 2 MPP architecture and distributed system to do this job at the same time. So that's where TigerGraph and Spark is a happy marriage together. And how we're facilitating the data flow between TigerGraph and Spark. So in version 2.4 and 2.5 of TigerGraph, we developed a JDBC open source driver for TigerGraph so that it enables the data flow in between Spark and TigerGraph. This JDBC driver is currently at the version 1.2, and it's a type 4 driver, and it supports read and write bidirectional, and it supports a read endpoint for both the built-in and the compiled GSQL queries. It's open source. You can find that in our ecosystem open source repository. I want to do a quick demo here. I don't have much time left, but I want to do a quick demo here. Let me go to my browser. You can see everything. This is the repository. And let me first go to the, so actually the Databricks Azure cluster is on. And I also want to go to make sure that here, this is TigerGraph Cloud, that I already started a China Mobile machine learning demo. And this is coming from our starter kits that it's already prepackaged in the platform. You can register. It's free. There's a free tier you can try. And you don't even need to import anything. Just start a machine, and you can get to this Graph Studio is our developer SDK. You can design a schema, map data. So the schema, as I said, is very simple here. Map data to graph, load data, explore graph here, and I can pick, already picked 4 phones, and write queries. So all these are, if you go to TigerGraph Cloud platform, it's already prepackaged, and you can just play with it. So this is the GSQL query, feature collection query that we wrote to gather the 2 in-group and stable group graph features. I'm not going to go into the detail of the code, but one interesting part, this is the cum clause, that's a slightly different from SQL. That this is a new concept that you can aggregate during the graph traversal. So let me just run this query. Let me go to phone 1, and duration limit here is for the phone call 60 seconds. And I'm going to give another number of call limit is 6, and run the query here. You can see here that we can find phone 1 with these 9, 10, 8. These are in-group connections. And then they also have connection as 2, 6, 5, 7. Let me go back to Databricks. I have already installed our JDBC driver here. You can just get a jar from the GitHub and upload here. And let's go to the workspace, TG Cloud demo. I have 2 very simple query here. So this is how the JDBC driver works in Databricks. And you can put, the vertex here is phone, and the limit here is choosing 10 vertex. Let me change to 8 and rerun this. All right, so I think it's warming up a little bit for the Databricks cluster. It'll take a few seconds. Yeah, this is usually what I see, that when I come back to Databricks, the free tier, it will have a few seconds to warm up. All right, now it's running comments. All right, you can see that here, this is the vertex ID. It randomly chose, 8 vertex, and the flag here is 0. It's all like good phones for now. And the second query here, I'm also using this same driver, and this is the format. Getting the query. This is a compiled query that I just showed you in the TigerGraph platform. And the phone ID is 8 here, right? And duration 60 and 6. I want to change to 1, as we did. I demoed earlier in TigerGraph that phone 1. Let's see what happens here. All right, now you can see here there's 8 and 10, 9 and 10, and 8 and 9. So these are the in-group stable phone calls. So this is how we facilitated the data flow from TigerGraph to Spark. All right. OK, let me go back to my slides. We showed these 2 graph features, stable group and stable in-group connections. All right, here are some more of the resources. You can, if you want to try with the machine learning graph feature extraction queries, you can get registered at tgcloud.us and play with that model. It's already there. You don't even need to do anything. And JDBC driver is in our open source repository, so you can welcome you to do pull requests and modify your code, modify the code as well. And contact me at this email address if you have more feedback and questions. So as I said earlier, we actually did a project that implemented this very famous neural network case from Andrew Nguyen's Coursera course. So we did this webinar last week. So if you want to have more information on how to do neural network in TigerGraph, just check out this webinar. I don't have enough time to talk about it here. Again, this is the quote we start with. What I want you to remember, if you didn't remember anything, is real-time deep link graph analytics at scale is the differentiator for your machine learning pipeline. All right, thank you. Thank you for your attention and time.
Thanks, Emma. Okay. Questions?
Questions, yeah.
Okay, thank you very much for the talk. Very interesting. I have a question first about you are getting the data, I guess, for the phone companies.
Yeah, so we actually got from police and phone companies and also some online third party. So the project was China Mobile, right? So we are basically helping them to do the solution. So it's not a solution in TigerGraph. Yeah.
Okay, so
they're
if
just
you
using
use
the platform.
The phone number as the ID for the graph, is that right?
So there's the phone number, and then address is a phone and phone connection. Yeah, so there's the ID for each phone, and then also there's the fraud flag. So yeah, so
because I'm thinking in a use case, and I want to know if you solve this. Yeah. It is, imagine there is a user and he's using the phone, and is a good guy, is using in a good way. And then, sometimes you are not using that number anymore, so you go to your company and you say, I'm not using this number, and they usually reuse the number to a new user. Yeah. So in that case, in your system, you have the history of the previous user, and then a new user could use it in a fraudulent way. Yeah. So your system could be in a temporary situation where it can be saying that this number is okay, but it's being used to attack or in a bad way.
So that's why we actually have the expiration time as well, right? So there are 118 features, and then after a certain time, we'll make it expire. And also, I think in the business logic, they probably have this use case that, okay, if it's reused, there's certain switch there. So that's some of the detail that probably it's in the model as well. So, yeah. Or if it's not, I think we should suggest them to do that. So.
Nice use case, Emma. I wondered is, of course, room also in the performance of the lead time of informing the user, which is the actual caller. So are there any developments in improving that performance? Ideally, you would like to see the number of calls made with a bad phone to be minimized.
You mean the lead time for when you see the phone call and then
I
repeat the
mean
question?
that you want to minimize the number of calls to be made with a bad phone.
Oh.
In the end, of course, the bad phone will be abandoned because it's not being effective anymore. That's something that you would like to minimize, right?
Yeah, well, so one thing that when the user, when they see the phone call, right, and they actually have a choice of actually picking up and not. It's not like the system will notify that, okay, it's a fraud. Yeah. It's very likely to be fraud, like the high percentage, right, because it's still a machine learning model. So the users still have the choice to pick up or not. So at some point, yes, I think your optimization, objective should also put into this model. Yeah.
Okay.
Yeah.
Thanks. Any other questions? Just one there. Okay.
Thank you for the talk. I wanted to know if the scoring is done offline or do you do it real time?
It's real time. Yeah, it's done in the TigerGraph. Yeah.
And is the feature generation real time?
Yes, feature generation is real time as well. Yeah. Model training is offline. Okay. Yeah.
And when the feature generation is real time, do you have SLAs on the latencies for generating the features?
So I think in this case, we try our best. We don't really, I think China Mobile itself, it's not like a necessary feature, right? It's not a must feature for China Mobile, so it's a very nice to have feature. So as long as it's reasonable within, okay, when the phone calls and then within seconds, the result will be notified, that's good enough for China Mobile. So that's, I think, sub-second time frame is our SLA. Yeah.
Okay. Do you have any benchmarks around those numbers?
For this specific case, we don't, but we have benchmark against a lot of other graph database and stuff. So in terms of the real-time performance and multi-hop, traversal time, and also loading time and storage compression. But for this specific case, we don't have how fast it gets to the phone.
Thank you.
There's one question there.
Thank you, Short, for the sharing. So my question is this product an online service? That means if our application want to use this service, then I need to build a connection to that, to TigerGraph, right?
So this particular use case is not, like widely available for everyone to just get get a service out of it. But it's actually a good suggestion for a future product. And the other thing which is readily available is the one that I showed you at the TigerGraph Cloud. That specific machine learning graph feature model is actually already there. So you can look at that, spin up an instance of TigerGraph for free, and look at the queries and to see how we did that two-feature graph feature extraction. So, but in the future, it's a good suggestion that we can put these kind of collection as a service as well. Yeah.
Okay, thank you.
We have time for one more question. Okay. You are the lucky one.
Thank you. It's very interesting. I'm just wondering, is there a plan, or do you support graph embedding techniques like deep walk or Notifac?
So we are investing a lot of resources in machine learning. So this is one of the projects that we are already doing some of the research. So stay tuned. So
thank you.